In this video, I want to talk about the control points and the spans for your surfaces. One of the reasons why I want to talk about this is because there's always some confusion between the type of surfaces which are trimmed and untrimmed. For example, this surface here, this is an untrimmed surface. And then here with this other surface, you'll see that it extends further. And if you shade it, you see that it's not shaded here because it has been trimmed. So this is a trimmed surface. This is an untrimmed surface. And here you have this untrimmed surface, which is tangent to this trimmed surface. So the reason why I'm using this specific example is because I want to talk about the advantages of using a trimmed surface or an untrimmed surface. So in this example, it's kind of clear how it worked. We created this simple fillet and we trimmed it so that we could have an untrimmed surface, which is easy to align. So this surface is very simple for you to select and align to get tangency on this side. So we selected this surface, the corner surface, and we aligned it by using the match command, and we did a match surface, matching one edge of this untrimmed surface to this trimmed surface, and we created something that is tangent. I'm not sure why it changed the edge. That's interesting. But so I don't want to get too deep into all the details of how the math works in the software and all of the degrees and the number of points that you need. But essentially, there's a lot of advantages to using an untrimmed surface. Once it is trimmed, you cannot really align the points which have been cut off. So there's just some major advantages. And so I'm going to go over how you can control the number of points, get really smooth results, and maybe even get smoother results, depending on the type of object that you're constructing. Okay, as I was talking, I was looking at the options. The reason why this surface kind of twisted in, and it wasn't following the orientation of the trimmed surface, the reason for that was because we did not preserve the ISO direction, and for some reason when we used automatic, it recognized that this is trimmed, and therefore it's just trying to line up to this trimmed edge. But we don't want that. We want it to follow the direction of these ISO curves or spans. The spans are on surface, the ISO curves are, in this case, they are the sides of the object because we're lining up to the entire edge. So ISO curves, by the way, are spans. It's another name for a span. An ISO curve is this type of contour that follows the surface orientation. So that's also important to know in this specific case, because ideally, we would want the number of ISO spans to be consistent from one surface to the other. And I'm going to explain that a little more. So what I'm looking at now is the number of points. And so for the sake of this example, I'm going to make sure I only use untrimmed surfaces. I don't want any of this type of surface here, which is trimmed. We want to have these clean edges where we can see each of the points. So for the sake of this assignment, I'm going to change the degrees, and you don't have to change it to the degree I'm going to be using. But here I can see there's 2 points, and here there's 2 additional points. So from experience, I know that this is a degree-free surface. And what I just did here is I typed in rebuild and pressed enter, and now I'm using the rebuild command. The rebuild command is essentially the best tool that you have for you to control the number of points or ISO curves, also known as curves, spans. And so it gives you controls on the parameters that you can change, in this case the points and the degrees, but also it gives you the number of points that you're currently using as this surface is right now. So this current surface has 4U and 4V points. So 4 points on the V orientation. And to see the V and the U orientation of your surfaces, you can look at these arrows. These arrows give you a hint on the orientation. And so if you know the software well and if you use this a lot, you'll remember which one is the U and which one is the V, just like the X and Y orientation of your, of your world space. But so essentially the U and the V are the orientation of the surface. So here we have 4 and 4. Let's not touch that, and let's just change the number of degrees and say 5 degrees and 5 degrees. And what we're going to see here is now we have more points going on the U and more points going on the V. And if we count the number of points, we're going to have 4 points. So it's kind of misleading, right? It said 5 degrees, but now we have 4 points to work with. And that's because actually we have an initial point, and then we have 5 degrees, which make up the curvature of the surface. Because with 1 point, you have no curvature, you have nothing. With 2 points, you can have a flat surface. So you have 0 curvature, you just have a plane. You have something that's flat. With 3 points, now you have curvature. So essentially, the number of points are counted this way. You do not count the first point for the degrees, and then you count whatever is after the first point. And of course, you can count the opposite side. It's essentially the number of control points that you have for your surface, minus the first one, because the first one is positioned to the surface, and it cannot really be aligned, so it doesn't really count. Because technically, I can align, let's say I had a degree free surface like this one. No, not like this one, like this one. So this is a degree free surface, it has 3 additional points. And if I wanted to, I can match the surface. So I'm typing in match surface. And so for surface, it's SRF. And so you can match, press enter first, you can match this surface to this one. And you can say you wanted curvature. And you can see it's actually having an effect on all of the points. It's having an effect on this point, and that point. Actually, not the last point, these 2 points, because curvature aligns the first and the second point, G1, G2. G1 is tangency, G2 curvature. So I'm going to undo that. I just wanted to show you how curvature works and how it pulls the points. But moving on with the rebuilding process, if we want this surface to line up to these 5 degrees, we should probably also do this on that surface and these 2 other surfaces, and make sure that these are untrimmed surfaces, not trimmed. So the way we'll do that is, again, we'll use the rebuild surface. We'll use the same properties here, and initially we had 3 degrees, now we want it to be 5 degrees. And again, if we look at the number of points, we have 2 points to line up to this surface and 2 points to line up to that surface. So if I match the surface to be curvature on each of the sides, now this transitional surface is actually curvature, which means it's very smooth. It's a little smoother than tangency, because the points are more consistent with the type of curvature that we have in this surface. So it follows this surface a little better because it's lined up in a better way, in a more consistent way, because it's using 2 points instead of 1. Now for this surface, we could technically do the same thing. So let's go ahead and just do that. We'll match the surface to this surface. And this time we'll use that feature we used before called isocurve direction, preserve the isocurve direction. And we'll do that on each of the sides. Now it keeps everything nice and clean, really smooth, a little smoother than before, just like here. You'll see that it doesn't follow the isospan, the isocurve that we have here. It doesn't line up with this one. One of the reasons for it is because the degrees are not the same. So here you have 5 degrees, and here you have 1 degree. So let's go ahead and rebuild that. If we rebuild this, and we make sure that we have 5 degrees on both sides, Now we have the same number of degrees, and as you can see, it's still the same. It doesn't line up. So the reason why it doesn't line up is because this surface here is a trimmed surface, but this one is an untrimmed surface. So that's one of the reasons why it's really important to know which one of your surfaces are trimmed, which one of your surfaces are not trimmed. Sometimes this is really important, sometimes it's really not that important. In this case, I really want to focus on this corner surface. So I'm going to pretend I did not see that, and I'm just going to keep going because I don't want to rebuild every single one of these surfaces just for the sake of building nice isospan relationships between my surfaces. It's not that useful to us. So I'm just going to undo. And okay, we're back to where we were before. So you can see this edge doesn't line up, and that's fine because we've already lined it up to be curvature, which means if we join these surfaces and we analyze them, you will see that they look pretty good. You can see that it's relatively smooth in between, and the tessellation I'm using for the mesh is actually relatively low. It's not very good, it's not very detailed. So I'm going to increase the number of polygons. And hopefully it's going to give us better results. Yeah, it's a little better than before. So I just wanted to illustrate that this has a nice relationship between this surface and this transitional surface. But let's move on and fix these surfaces. And the way I'm going to do that is instead of fixing these surfaces to create this transitional surface, because this one is trimmed, I will actually work on the untrimmed surface first. So first, we are going to align the two edges to the existing edges that we have, because we know this is nice and smooth, this is nice and smooth, and so if we make the corner smooth here, then we can rebuild this surface, we can just get rid of it. In fact, let's just delete it now. I'm just going to delete this corner surface that we just don't want to use because it's not, it's just a trimmed surface and we can get better results using what we have here. Yeah, so the strategy here is we're going to use the match command, match surface, and we're going to match this side of the corner surface to this other transitional surface and make it a curvature continuity. We can also preserve the ISO curve direction. That should work. That looks a little strange. Let's see the points. Okay. Yeah, the software crashed, so I made some changes, but I guess I still have to rebuild this and make it 5.5. I had a software issue, so the file I'm working on right now is not the same one I was working on before. So I'm going to undo this, rebuild that. It's going to take a second. Make sure it is an untrimmed surface, just in case. Show me the points. Here we go. So we're back to where we were before. So this is a degree 5 surface, degree 5, both ways. So all I have to do is match this surface to this one. And now it's nice and smooth with this transitional surface. So now we can do that again with this side. Let's try that again. Okay, so you have to be careful of where you click, because if you click on one side and then the other, the whole surface could flip upside down. And then for the settings, you want to make sure that you avoid the average surface, because average surface tries to make both surfaces tangent to each other, and in this case curvature for the fillet. So I think curvature here and tangent to the other side, or probably curvature on both sides because it's average. So make sure you do not use average surface when you match this corner surface to another one. And that's it. So now we have curvature continuity between each of these surfaces. So now that we have this corner surface, which has the type of relationship we're looking for, I guess all we have to do is copy it. So I'll just select this section and copy it 4 times. So make an array polar and snap to the center. We'll copy it 4 times. And now we've got everything we need except this surface here, which initially was a trimmed surface. So now by making a sweep, we can get a better surface which is not trimmed, and we can keep it curvature to this side. And here we have a bunch of options, especially this one that's interesting to us because we can build this transitional surface with curvature by default. And the reason why this is really cool is because now we can go here and we can simply match this surface, the ball corner, to this transitional surface. And now this is actually curvature everywhere on this side, and this side, just not this inner side. So to do that, to get the last side of the ball corner, we can make an array polar again, and just copy this last surface 4 times. And actually let's go in and delete the other corner surface because we only want to build one and then copy it so that it's consistent everywhere. So like I said before, this is curvature on each of the sides except this one. So let's match surface, or use the match surface command. And this time we'll use the last edge of the ball corner to this transitional surface that we didn't. Oh. Okay, let's try that again. This side and this side. Okay, and again we want to use curvature. So now what we've done is we've made this corner curvature on each of the 4 sides. And if we've done it correctly, it should be able to match everywhere. Now sometimes, depending on the number of degrees, you might get a little of a gap, and sometimes you have to do match twice. Match on this side and match on the other sides once again. So you go from one orientation to the other orientation. Sometimes you have to do it once and then a second time. For now, I think this should work. So I'm going to go in, make an array. So I've copied the corner surface 4 times. Now I'm going to join them. And that's it. So we've created nice transitional surfaces with G2 continuity, meaning curvature continuity between each of the transitional surfaces, between each of the transitional surfaces and the main surfaces, the major surfaces. And we did do some changes to some of the major surfaces. I think the main one was one of these surface here. Actually, no, yeah, we haven't touched the major surfaces. So this is a pretty standard way to build an object. You go in and you create your main surfaces. And then from the main surfaces, you want to create super clean transitional surfaces. And your transitional surfaces, these ones, they are not trimmed surfaces. So your major are trimmed, these ones, they are trimmed. But your transitionals, they are not trimmed. And this allows you to create this curvature relationship between your nice corner surfaces, the transitionals, and your major surfaces. So I hope this was helpful and that you learned something. One last thing I want to go over, or just quickly show you, is when you join these and you kind of compare the way they look, essentially they look exactly the same. But if we go in, let's do CAP, cap, so we're closing them off. So now they are solid objects or closed off objects. We can go in and analyze the edges, so we can go under surfaces, analyze edge tools, show edges, and we'll see that both of them have the same condition. They are both closed, they are both solids, so that's good. And now we can analyze it, and we can look at the zebra, or we can use at the EMAP. Emap is really nice too. It gives you a really good idea of how things would reflect. And if for some reason we have like some gaps, I saw there was a little bit of a gap up here before. So sometimes that's related to the mesh, so you can adjust your mesh, and if you increase it, it should give you a higher resolution here. Now, in this case, it's still not very good. So you can go under the detail control and you can crank up some of these settings. So usually the way to do this is to set pretty much everything to 0. Minimum, I'm going to set it to 0.1. Actually, let's do 0.01. I'm going to enter somewhat of a random number down here, and then I'm going to say maximum edge length 0.1. And let's see what it does. Okay. So it gives us something a little more consistent, but not really dense enough. So if I say the maximum length is 0.01, it's going to give you something a little better. Yep. Okay. So now we have something that's essentially it's way too dense, which is good, because when you go from something that is not dense to something very dense, you can kind of find the middle ground. So let's say we want something like 0.05, 0.5. So now we made this a lot bigger. Yeah, it should do a really good job. So let's do a quick preview. It's going to take some time to generate, but it should be a lighter mesh, because we don't want it to be too large, otherwise, one, it could crash, and two, it takes more time for you to rotate the view to kind of analyze the type of surface that you're looking at. And so as you can see, now that we have a very dense mesh, we can see how this highlight is really nicely, it's carrying on very, very nicely. And so what that means is that we have a very nice continuity between these surfaces which are more flat and these which have more curvature to them. And so it gives us an idea of how smooth the continuity is between the surfaces. And there is somewhat of an edge here, so sometime it's good to actually go back, explode, go in and match, and maybe we can match this side to this one. Cancel. Let's try that again. Okay, and I matched the wrong side, so the one we wanted was this one, matched to this one. Okay, and you can see it's updating. We want it to be curvature, okay. And yeah, so it seems like when we're matching one side to be curvature, we're losing curvature on the other side. And the reason why I know that is because there seems to be somewhat of an edge here. Yeah. So there's a few reasons why this might happen. One way to resolve it would be to rebuild it. Usually if you add a few degrees, it makes a big difference. It makes it a lot easier for the surface to adjust. So this would be the time to increase the degrees. And so the whole point of this whole video, it's all about thinking about how many points do you need to get the type of surface that you want. And essentially, when you look at these surfaces, they're the same surface, right? There's not that much of a difference. So I'm just being really picky about how far I want to improve this surface, like how much better I want it to be. But I think you get the point. I mean, here you have this nice highlight, which is essentially it crashes into the other surface. The relationship is, it's tangent, so it's okay. But it's not very, very smooth in between this surface and then this one. But here you can see that you do get better results. You get a smoother transition in between, but still, once you adjust one side, the other side kind of loses that relationship. So by adding 7 degrees here, I should have enough control specifically for this ball corner to be aligned to each of my sides. So let's just go in and just do that really quick. We're gonna match the surface, and we're gonna match this side to this side. Press enter, and now we're gonna remove the preserve isocurve direction. because it should already be aligned correctly, and I don't think that by using automatic it would change anything. Yeah, so these settings should do the job for us in this case. So we're using curvature, we have a 7-degree surface, which means we have a few additional points that we are not aligning. And let's do this on this side, and the same thing on the other side. Okay, and now you can see we're not getting as much of an edge here. And if we did it one more time, I believe it should be able to give us a nice curvature here, curvature there, and there. Let's see what it does. Could be wrong. Yeah, it's much better. So you do see somewhat of an edge, and the reason for that is because I haven't joined these surfaces, but once they are joined, usually it's going to fix up that small gap and give you something much smoother. So here you go. So that's the whole purpose of this video, right? We're increasing the degrees from being tangent, from being degree-free surfaces for our transitional surfaces. We're increasing the points to degree 5 so that we get curvature for these transitional surfaces. And then just for the ball corner, we saw that there was a little bit of improvement that we could achieve, except we only had 5 degrees, which is not enough to make any type of improvements. So all we have to do is rebuild it once again and add just about 2 degrees, maybe 4 degrees if you want to be very, if you want to create a heavier surface, which is fine too. If you wanted to use 9 degrees, that would be okay, or even 7, 8, 6. But just by adding more degrees than what we have, so adding a little bit more control to our surface by adding more points, gives us the control we want to be able to achieve this really nice continuity. So I hope this makes sense, and I hope that you understand the basic principle of how to create transitional surfaces, and that you have a better idea of when it's appropriate to use trimmed surfaces and when it is better to use untrimmed surfaces.